Yeah, so my name's Sam Blair. I'm a master's student in plant breeding, and I'm with Dr. Danny Singh, and we work on soybean breeding. Yeah, so essentially the goal of this project is to develop a drone and machine learning pipeline to make soybean relative maturity classifications more easily. All soybean cultivars, new soybean cultivars, will have a slightly different maturity, so that means they will grow and die at different rates depending on their genetics. And currently the way we do this is very time-consuming and laborious. It takes tons of raters to go out into the field several times a week over multiple weeks, observing every single plot in the field. And so our goal is that we can move that from a manual data collection process to a drone and machine learning process.
Hi, I'm Chloe. I'm a graduate student in computer engineering. I'm working with Dr. Bhaskar. Our project primary goal is to develop machine learning tool to predict maturity rating value of soybean plot. So we'd like to develop automatic machine learning tool instead of doing manual work. So we expect we can get reduced labor work process by up to 90%. Yeah.
Currently, the way this pipeline works is we take our drone and we kind of match when we would normally go out and observe the field manually. So we'll fly the drone over the entire field, taking images as it kind of follows a serpentine pattern throughout the field. We take all those images, we combine them into one big image, we segment out each plot, and then we take our drone flights multiple times a week, just like we do manually. And from that we can see how quickly each plot loses greenness, and kind of what our machine learning model is attempting to do is to plot that greenness, that loss of greenness over time, to be able to tell differences between plots and make the appropriate rating. So we're getting up into the 80% classification accuracy, so we're about 85% accurate at being able to really accurately tell what the maturity rating for each soybean plot is.
In our case, the color of plot is the main feature in our project. So I extracted all color value from each plot image and then try to create a 2D control plot, which means x-axis means hue color range, and then y-axis means time, and z-axis means a number of pixels. So after that we transform that 3D plot into 2D plot. So it's gonna be it's gonna be fed into CNN model to predict and classify maturity rating value. Our model has shown kind of high accuracy, over 75% of 5 classification, but we did so many different classification based on different stages of class. So with 4 classification we got over 80% accuracy. So we're still doing improving our machine learning model.
This potentially could even be used in a farmer setting. So our purposes right now are more breeding, targeted towards breeding programs. But a similar system could be implemented to a row crop farmer. If they were willing to use a drone to scout their fields, they could potentially use it to see when their fields have reached maturity and are ready to harvest.